All right, so now we're looking at temperatures inside and outside of a house given by these two functions here. Find the temperature inside the house at 8 a.m. So reading the question carefully, we can see that our time t is hours after 4 a.m. So 8 a.m. means a time of t equals 4. So at t equals 4, our air temperature for inside the house is given by our function here. So we've got 21 minus 3 cos of 4 pi over 12. Well, of course, that simplifies to pi over 3. I know that cosine of pi over 3 is a half. So 21 minus 3 halves is 19.5 degrees Celsius. Now we want an expression for the difference in temperatures. So I'm going to subtract my two equations. So equation D is 22 minus 5 cos of pi t over 12. And, oh, sorry, that's my equation B. So that's what I'm subtracting from equation A. And equation A is 21 minus 3 cos pi t over 12. So we're subtracting this. All right, so 21 minus 22, that's -1. -3 plus 5 cos. So they've got the same input. So this is like adding the same variable. So I can say that's going to be plus 2 cos of pi t over 12. So there's my function for the difference. So I'm thinking about the difference in temperatures, and I can see that my center line is at -1, and then I'll go up 2 and down 2 from there. So I'll have a maximum difference of 1 degree and a minimum difference of -3 degrees. All right, so sketch my D. So since my center line's at -1, I don't like this axis being here, so I'm actually going to ignore that that was drawn there, and I'm putting in a better axis more towards the center. All right, so just move that down just a touch so it's actually on the line. All right, so I'm going to put my t-axis to actually be here. And so -1 is my center line. So let's see, if I put my -1 here and then go down to, this could be my minimum line down here at -3 and my maximum line up here at 1. Okay, so I'll think about those. My center, and I've already got my minimum labeled down here. I've got a cosine graph, the period of this graph. So my period is going to be 2 pi divided by pi over 12. That's going to end up giving me 24, which makes sense because we're saying 24 hours or 1 day is a single period. And let's see, I want a graph for 1 full day. Okay, so this is cosine. So we're going to start at its maximum. And let's go ahead and count out. So there's 6 hours, and then 8, 10, 12. And then we've got 18 and 24 hours. So we'll be back at our maximum after 24 hours, down at our minimum after 12 hours, and then 6 hours halfway between. So put in my graph. Trying to make smooth curves. Whoops. All right, so there's my difference graph. So this is modeling my difference in temperatures. Determine when the inside temperature is less than the outside temperature. So remember, this first part was my inside temperature. So we had inside minus outside. So inside minus outside. Oops. So if my inside temperature is greater, I'll end up with a positive value. If my inside temperature is less, I'll end up with a negative value. So I'm looking for, in part D, I'm looking for the areas where my difference is less than 0. I can see that my difference is less than 0 between these values. So let's see if we can solve this equation. So if we say that we want our difference to be less than 0, here was my final equation for difference. We had -1 plus 2 cos pi t over 12. I want that to be less than 0, so add 1 to the other side, divide by 2. Cosine of pi t over 12 has to be less than 1/2. Well, this is one of the ratios I know. I know specific angles that this is true. So I know that theta is going to be equal to pi over 3 when cosine is 1/2. I know that that would be my reference angle. The other time that it's going to be positive, because I see that there's two solutions. So knowing, of course, that cosine is positive for theta here or here, so my other theta value could be 2 pi minus pi over 3, which of course is the same as 5 pi over 3. So those are values of theta. Well, my whole section here represents my theta. So that means that pi t over 12 equals pi over 3, or pi t over 12 equals 5 pi over 3. Now I can solve these equations. Multiply by 12 over pi. I'll get that t is equal to 4, or I will get, if I multiply by 12 over pi, times 12 over pi is going to cancel. I get that t is equal to 20. So looking up here, if my curve had been perfectly smooth, my values would have been exactly at the 4, and over here it was really close to the 20. So determine when the inside temperature is less than the outside. It's between the hours. So when t is equal to 4, we know that's the same as 8 a.m. If t is equal to 20, that's so 4 a.m. plus 20 hours